right, here we go. Lesson 3.1. It's a chapter on mainly congruent triangles is our topic. But we start off looking at what it means to have corresponding parts. So let's write out that big word. Yeah. This is kind of our bookends. We start with this and we end with corresponding parts. All right, hopefully you see in here a diagram of two triangles, kind of sitting one on top of the other, elevated. And we can see that they look pretty much the same. And furthermore, we have arrows that indicate, and those arrows should be going both ways. They indicate corresponding angles. So if triangles are congruent, and we are mainly talking about triangles, though this could apply to any polygon, then, don't forget about that symbol, then the corresponding parts must be congruent. So, for example, if you look at segment AC, and I'll highlight that here, then the corresponding part would be FD. Make sure you put a segment over it. All right. And likewise, if I take angle D, sitting here, the corresponding part would be angle C. And we could continue that process of looking at those individual corresponding parts. Let's do that here in a little exercise. We're given two triangles. They're side by side. We are told here that triangle ABC and XYZ are congruent. And by the way, this is technically all we need to look at is this statement here. They forgot, once again, I hate it when they do that, to put the little congruent symbol in there. All right. Anyways, we don't need to see the picture if all we have is the statement. Okay? That should become clear when this exercise is done. So the first question is, how many are there? And then can I name those corresponding congruent parts? Since every triangle has three sides and three angles, the first question is answerable with the number 6. So how many? There's 6 parts. All right, that's why there's 6 lines, and we will go ahead and put little congruent symbols between each of them, and we can start through naming the angles. So in this case, angle A corresponds with angle X. Angle B is corresponding to angle Y. And angle C is corresponding, and I should be saying congruent with each of these, angle Z. Notice how we can zoom into this without the diagrams and see those congruences because of the position they are in listed. And that is important. Okay? So side, for example, AB, corresponds to and is congruent to XY. And BC is congruent to YZ. And CA or AC, you can name it however. Though, if you name it CA, you should then proceed to name the other side as ZX. All right? Definition. If two shapes, and by shapes we mean polygons, yes? Specifically this chapter we are looking at things that just have 3 sides, so we won't be looking at 4-sided shapes, that kind of thing, till future. But if two shapes are congruent, then all the corresponding parts are congruent. Okay? That is our definition of congruent shapes. And again, you could specifically say this is true for congruent triangles. Now, as I've already alluded to, order is important. So if I were to say triangle TIK, T-I-K, is congruent to, they should have used an O here instead of an E. That's a shame, yeah? Would have been a nice little nod to angle TEK. How do I know that that's the right order and it's not the angle KET, for example? Well, we can see here that angle I is congruent to angle E because it's got the double angle marked. Yes? All right. So angle IT is congruent to angle, and then we would need to start with E, T, K, ETK, and KE corresponds to KI. Now here we're given a diagram and we're given some information, and we need to state true, false for each of these statements that they're given to us. Let's zoom in on the diagram to see what information they've given us. FP, bam, that ray right there, bisects this angle and this angle. GP bisects. All right. And so I'm going to use a double angle there. Angle 5 and 7 are congruent. Oh, well, look at that. Angle 5 and 7 is congruent. I can like remove one of those each. PF is congruent to PG. So P to F and P to G are congruent. And Q to G. All right. So that long distance there, yes, is the same as that long distance here. Hard to mark that one on the diagram because those are overlapping pieces. Yeah. All right, we won't mark that on the diagram, we'll just highlight it here. Is angle QFC congruent to angle RGF? Well, let's go ahead and mark that on the diagram. QFG and RGF. And we would have to say, yeah. Why? Well, we have a theorem from this last chapter 2 that was called the multiples, right? Remember, we have if 5 and 7 are congruent, and then you double it, right? Because you create a bisection there. We have a larger angle, therefore then that one is congruent. Next, is QP congruent to PR? So QP and PR. And we have to say, well, yeah, if you have the big segment and you take away the little segment, and I have the big segment and I take away the medium segment, then I'm left with those tiny segments left. So that's called the subtraction segments theorem. So that was also true. Angle 7 is an acute angle. So angle 7 is right there. And we know angle 5 is an acute. So then by the substitution, and this would be the fact that we could substitute 5 with 7 since we know that they're the same. So it's technically called a substitution theorem, book calls it the property. I guess I'm not going to give it on a shape, but because, well, in this one here, either one is fine, property or theorem. Okay. TF, true false on fer and angle jec. So angle fer, F-E-R, and angle jec. Now this is a really important one. Notice those two angles, they're named differently, but they're the same angle. They're just talking about this angle right here, angle E. So is angle E congruent to angle E? And we would have to say, yeah, those two angles are congruent. You're going to use this one a lot. So not only should you write this down, the reflexive theorem, and this means that, for example, we can say A equals A. In this case, we're saying angle A, and that's why I said theorem. Angle A is congruent to angle A, right? All right. Highlight this one in your list. It's an important one. It will come up again and again and again. Okay, and it's one that we don't, initially it's like, I don't know why you're equal to yourself, because you are yourself. All right, that was lesson 3.1.